Hey, welcome back. So the first of the fancier sorting algorithms that we're going to take a look at is called merge sort. It's a very well-known one. It was created back in 1948. A computer scientist slash mathematician and all-around smart guy named Jonathan van Neumann wrote the first ever recorded program of merge sort. It was 23 pages of code for this computer here called EDVAC. It's a very large computer. It was like 6,000 or so vacuum tubes. Writing code back then, obviously very different than it was today, but the algorithm, the idea, was first conceived in 1948. So the idea behind it, it's really a combination of two things, merging and sorting. And actually, you could say it's really a combination of three things, splitting up, sorting, and merging. All three things take place. So it exploits the fact that arrays of 0 or one element are already sorted. So if you were asked to sort an array that just consists of the number 1 and that's it, you know it's sorted. Or it's just the number 9, it's sorted. Or it's empty, it's sorted. So merge sort takes advantage of that fact. It works by decomposing an array into smaller arrays. So that's something known as a divide and conquer algorithm, a divide and conquer approach. We split up the larger array we're trying to sort into smaller sub-arrays. All the way down, we keep doing it until we get to 0 or 1 element arrays. So we would take an 8 element array and split it, and then split it, and then split it until we end up with 8 single element arrays, and then we merge them back together. So here's a little visualization. Imagine we have this array here, 8, 3, 5, 4, 7, 6, 1, 2. That is 8 elements. What do? We start, or the code starts, by splitting it in half. So we're dividing it. And we're still not at 1 or 0 element arrays, right? These are 4 elements, so we split again. And now we have 4 2 element arrays. We're still not there, so we split again. Now what we have are 8 single arrays, single element arrays. So now we merge them together. So let's focus here. We take these 2 arrays and we merge them back. And as we merge them, they are already sorted. We know that they're sorted. So merging 2 sorted arrays is easy relative to merging 2 unsorted arrays. So what we do, we basically just compare the number. Which one is smaller? Well, the smaller one goes first. Which one of these is smaller? Smaller one goes first. Which one of these is smaller? Put that first. 1 goes before 2. Then we repeat the process. Now we're merging this array with this array. But notice this is already sorted. This is already sorted. So now we just make a couple comparisons. Take the first item, compare it to the first item. Which one is smaller? Put that one first. Then we take this item, compare it to that item. Which one's smaller? Okay, put 4. And then we do it again, put 5, and then 8. And then the same thing over here. So we end up with 1, 2, 6, 7, and 3, 4, 5, 8. 2 sorted arrays that are smaller. Now our final merge, we put them all together. And we end up with this 1, 2, 3, 4, 5, 6, 7, 8. So hopefully you can see, yes, this algorithm is a little more complicated, but it involves first splitting up until we end up with sorted arrays, which are 0 or 1 element. That's the base case. That's the smallest thing we get to. We know they're sorted if they're only 1 item long or they're empty. Then what do? We merge them. Merging sorted arrays is easy. Well, compared to merging unsorted arrays, still not that easy. And we sort them back until we finish and we get a totally sorted array. Here's another visualization. Here we have 8 elements in an array. And the very first thing that happens is we split them all up into 8 individual arrays. So now they all have, each color represents the fact that they're an individual array. And then you'll see as we merge them together, they change color. So it starts with the first 2. These are 2 arrays. How do we sort them into 1? 3 and 44. It takes them out and puts them back in that order. They're sorted. So now we have, this is 1 array here. So we have 7 arrays, right? Oh wait, 1, 2, 3, 4, 5. Yes, 7, I can't count. So next, we take these 2 individual arrays and we sort them into 1 and put them back. Now, we take these 2 arrays, the orange and the red, of those 2 items each, and we sort them into 1 array, like this, and then we put that back. Then we have to start on the right side. So this was the left division. Now we take 47 and 15, we sort them from 2 arrays of 1 item into 1 array of 2 items. Same thing with 36 and 26. Now what do? We merge these 2 arrays together, the yellow and the green. There we go. put that back in, and now we merge our two arrays of 4 items at the very end. There we go. So that's merge sort. And as you can imagine, there's a little bit of logic involved. In the next video, we're going to implement the first step, which is merging. So we have to understand how to merge 2 sorted arrays, and then the rest is actually pretty easy. So in the next video, we're going to cover that. We're going to build a merging function.